great. Woo! All right, here we go. Ready to rock and roll. So I already introduced myself, but the last thing, my Twitter handle is Camille. Please feel free to tweet me with any comments or feedback or questions if you have them after the talk. I'm always happy to answer if you're not comfortable raising your hand right now and asking me anything. All right, so you're here because you are interested in Storm, a member of the Storm community, maybe a member of the Hadoop community here in New York, interested in big data, probably. You are dealing with it, thinking about it, worried about it. And there are a number of, big data is the hot thing right now. We've got Strata, Hadoop World coming into town next week. That conference has grown and grown and grown humongously over the last few years. And part of the reason that big data has become such a big buzzword and topic is because we've started to really have this blossoming of open source systems out there that are built to handle big data and make it easy for people to process it without having Google's budget to actually create internal software to do so. And these systems are kind of pretty varied. You see you've got Hadoop, you've got Apache Solr, which was originally built to be sort of a single point that's been turned into Apache Solr Cloud, where you can run multiple servers to do your indexing. We've got Storm, which doesn't really have an icon, but this is the best I could do, which all of you hopefully are fairly familiar with. And we've got Kafka, which also doesn't have an icon. And so, these systems and many others are big systems, big data systems. They were designed to be able to process many gigs, many terabytes of data in some manner, batch, real time, what have you. And in order to handle that volume of data in a reasonable time period, not taking weeks and weeks and weeks to get you the result, these systems basically had to become gigantic, big distributed systems. So they're processing this big data, you've got these giant, big distributed systems, and you end up with a number of challenges that all of these systems face because they're dealing with, by their nature, they have to be these big distributed systems. So what are the challenges? You've got the challenges of outages. I'm sure everyone in this office, if you're running Storm in production or any kind of big system in production, you're familiar with thinking about outages, right? What happens when a node goes down, when a network partition, when a disk corrupts, what happens, right? What happens when you have something go wrong? When you're building a big distributed system, especially the architects of those systems, they have to think about outages at the beginning, right? You cannot build a system where it's not available if a single node goes away. Nobody's going to use it, right? Why would you ever run a system with 50 nodes in production if every single node has to be available for your system to work? So outages are a first-class citizen of concern for any architect working in a distributed system. Coordination is another big challenge that you have to be dealing with, right? Who's doing what's task? How do I know, that everyone has finished task A and can move on to task B? All those kinds of issues, right? Coordination is a big challenge when you're dealing with task-based systems, and many of these systems are. And then there's just the simple issue of operational complexity. When you're talking about running tens or hundreds of nodes of a system, you do not want to force your admins to have to go in and SSH into every single one of those systems and change files and configure things and twiddle knobs to bring your code up and running. You don't even want them to have to run a chef script to do that. You really do not want to have humans touching every single node all the time to configure things and to change things. And so you want to really reduce the operational complexity as much as possible. Most systems also have a fairly common deficiency, which is that most of these big distributed systems don't have great consistency guarantees. Okay, maybe they're eventually consistent, whatever eventual means, but depending on the failure modes and depending on the modes of operation, it's hard to know when you're going to get the final answer to a piece of data question, right? Is this data actually in its final state? Is it still changing? How do I know? Even in a database, right? This is actually a non-trivial thing to do. How do you know that someone hasn't written a piece of data to this table that you are going to try to write to just throw in this table? You have to put in timestamps and be checking and put a bunch of transactions all over the place. It's non-trivial, even in a database. And most of these NoSQL systems don't even really try to give you a huge amount of consistency guarantees and ordering guarantees. So these systems all have very common challenges, and they pretty much all have this common deficiency. And so this is where ZooKeeper comes into play, because ZooKeeper has the ability to help with all of these problems, and it has that ability because it has very strong consistency guarantees and strong ordering guarantees. So quickly, what is ZooKeeper used for in Storm? It's used for coordinating the cluster. So one of the basic things I just listed there, right? Coordination, huge issue. That's what ZooKeeper is doing in Storm. It's not used for message passing. It's not used as a gigantic cache. It's not used for any big complex thing. It's just simply used for configuring the cluster, coordinating the cluster, I should say. And so what is ZooKeeper and why is it the system that all of these different projects are using for solving these problems? So ZooKeeper, centralized service for maintaining configuration information, naming, providing distributed synchronization, and providing group services. All right, I'll go into what all the heck that stuff means in a few minutes. But basically, ZooKeeper is a distributed, consistent data store. Favors consistency over everything else. It is still highly available, so it's built to be a distributed system. It's not built to be a single, standalone, whatever. But it is built to favor consistency. It's also a high-performance system. So believe it or not, ZooKeeper actually performs very, very, very well under heavy load. And it is designed with performance in mind, so it's not slow. The idea is that you can really do a lot with ZooKeeper and get results very, very quickly, so that if you happen to have to put it on a critical path somewhere, it's not going to drag you down too much. Finally, ZooKeeper provides strictly ordered access for data. So you really know when you're dealing with a piece of data, the state that that data is actually in, and you can trust that as you access data, your ordering that you are modifying data in is going to be preserved by the system. So what do I mean by these things in particular? Highly available. ZooKeeper tolerates a minority of ensemble members being lost and will still continue to function. Minority means if you've got an ensemble of in members, you can tolerate in number 2 minus 1 loss. So if you have 3 nodes, you can tolerate 1 node going down. If you have 5 nodes, you can tolerate 2 nodes going down. This is ZooKeeper Basics 101, but this is an important point. If you are running ZooKeeper, we recommend that you run an odd number of nodes because you don't really get anything from running an even number of nodes. If you run 4 nodes, you can still only tolerate the loss of a single server before your ZooKeeper becomes unavailable. So generally speaking, we advise running 3 or 5 if you're going to run in production. Do not advise running a singleton node, even though some of the Storm documentation sort of indicates maybe that's what you should do. I don't personally advise that unless you don't care about your system being unavailable if your ZooKeeper goes away. ZooKeeper is high performance. How does it maintain that high performance? All the data is stored in memory, which means that it's been benchmarked at around 50,000 operations a second. To be honest, ZooKeeper benchmarking is a question that we often get on the mailing list. Can I do this? Is this going to perform well enough for me? And the real answer with ZooKeeper benchmarking is if you really, really, really care about the numbers, you have to benchmark it yourself because it will depend on your networks, on your servers. Is it on physical hosts? Is it on cloud VMs? Is it writing to its own disk? Does it have its own transaction log, separate disk, separate from other things? Or is it sharing a disk with something else that's chatty? All of those different things can affect how fast your ZooKeeper actually is able to process transactions. So if you're concerned with the ZooKeeper performance for whatever reason, hopefully you won't be, because I personally don't recommend putting ZooKeeper someplace where you're going to be super sensitive to performance. But maybe you have a project and you really think this is the right thing, and you really care what's the performance that I can get out of this, how many things can I tolerate, how many writes am I going to get through, how many reads am I going to get through. Benchmark it yourself. There's great tools online for doing that. If you go to the ZooKeeper webpage, you can find those. ZooKeeper is particularly tuned for read performance. So if you were doing a read-heavy, write-light workload, ZooKeeper is a good bet. That's because reads are always serviced out of the node that you connect to, your client connects to. They don't actually have to do any kind of voting or any kind of consensus to get that value. Finally, strictly ordered access. This is really, in many, many ways, the killer aspect of ZooKeeper, and this is the reason that you use it. This is the reason that it's out there. In particular, we guarantee a few things. We guarantee atomic writes. If the write is either going to completely succeed or it's going to completely fail. It is not going to get into any kind of weird half state. It is you will give you those atomic rights in the order that you send them to the ZooKeeper. So your client says write value X into node A, then she says write value Y into node A. You are going to see X, then you're going to see Y. That's the order that they will be received. No one's ever going to see Y and then see X. That will never ever happen. That's very important. This is not a guarantee that a lot of systems provide you. Changes are also seen, but in the order that they occur. So you're going to send them and have them act in the order that you sent them. They'll be seen by other people in the order that they occurred. And it's very reliable. If it acknowledges a right, you're not going to lose it. Are any of you guys familiar with Kyle Kingsbury's Jepsen work? Oh, few people. Okay, it's very cool work. Jepsen, if you're familiar with Kylie Ray, the Call Me Maybe. Anyway, it's a couple, okay, a few more recognition. So he's done some really cool analysis of the ways that these various distributed systems fail when they fail in production. They all sort of hand wave in their documentation, oh, you may or may not lose data. And he's done a lot of work in showing exactly how you can expect to lose data if you've got really heavy loads going against your NoSQL store, and one of them fails. And he's done this with ZooKeeper, and pretty much nothing failed. So we feel very good about that proof out there. He's not tortured ZooKeeper nearly as much as some people, actually. I think Facebook has done a lot more torturing of ZooKeeper than he has. But it's a good proof that ZooKeeper really does live up to these guarantees, because that's what it is designed to do. So any questions about these basics before I go on to some of the additional basics? Okay. Cluster interaction. So what does ZooKeeper actually look like? All right, you've got an ensemble, you've got a leader, and followers. All right. How does ZooKeeper work? ZooKeeper starts up. It goes through a voting algorithm that I'm not going to describe, because I'm not sure I could if I wanted to, whereby one node of the cluster is elected to be the leader. You will always only have one leader, and that is very important for many of the guarantees that ZooKeeper provides. So you create an ensemble, you get a quorum, you have a leader. You have a bunch of clients, and they connect to nodes of the ensemble. Now, the clients can connect to the leader, they cannot connect to the leader, you can configure that. If you're not doing a huge heavy load, it doesn't really matter. If you're doing like a ton of writes and you really want your leader to be optimally able to just concentrate on writes, you probably don't want nodes, you don't want clients connected to your leader. When clients connect to a node of the ZooKeeper cluster, the clients are creating a stateful session. That means that they are heartbeating back to the node that they are connected to at all times. Right? You have an open socket open to this cluster at all times, as long as you've got your ZooKeeper client open and alive. This is important for a few things we'll get to in a minute, but this is just an important thing to note, right? One of the bottlenecks if you're running a gigantic ZooKeeper, or you're running like a majillion clients, is that the number of sockets you can have open on a box will limit the number of clients that can connect into each individual server. So if you are planning for hundreds of thousands of clients, you actually need to think a little bit. If you're not planning on for hundreds of thousands of clients, no big deal, this is no problem. So what happens when a cluster member dies? So if it dies, we've still got enough to have a quorum, they can still talk to each other, no problem. But that node has gone away, and clients will see a disconnect event, at which point they will reconnect themselves to another member of the quorum, and as long as they do that within their session timeout, their sessions will still be alive, and nothing will change for them in terms of session state. So this is very useful because some of the basics of ZooKeeper are session-based, and so you want to be able to keep your session alive if you're actually alive, even if a node of the ZooKeeper cluster goes down. So this is the sort of basics of cluster interaction. Any questions about that? Yes?
So if you have a single node ZooKeeper cluster,
yeah,
you only have, it's running the leader and the follower?
If you have a single node ZooKeeper cluster, it's not running a leader and a follower, it's just running the standalone singleton ZooKeeper.
Okay.
So there's no voting to be done. You either see it or you don't, and it's there. So, yeah.
Maybe a very silly question, but I mean, we are talking about high availability about ZooKeeper, and then the client can overload the certain time, So why do we need a leader at all? We can have equal distribution like how any clustering has. Why was the concept of a leader coming up first of all?
Okay, so why do we have a leader in ZooKeeper? The leader is required because the leader is a core part of the ZooKeeper atomic broadcast algorithm. That is a consensus algorithm. So Axos is the classic consensus algorithm that you may have learned in school. Notoriously difficult to understand and implement. ZooKeeper atomic broadcast, also, P.S., notoriously difficult to understand and implement, but at least has been implemented correctly because the people that invented it did it inside of this system.
Yes, we can discuss this offline, but Paxos algorithm is also used by other NoSQL databases like Cassandra. They don't have any concept of
yeah, we can definitely discuss that offline, but ZooKeeper's algorithm is a leader-based algorithm. You have to have a leader for it to work. If the ZooKeeper atomic broadcast protocol relies on the leader to provide certain of the guarantees around that consistency and ordering. So without that, it will not work.
If they had, this was the initial concept, I'm not sure why they are not changing it. So that's a question for probably the Apache ZooKeeper.
Sure, we can discuss offline why we wouldn't be changing that. Yes.
So you said that the session is still intact. Does that mean that the session is being replicated among the cluster as well? Or is it, I can't imagine it's sort of fine.
I think it is, the session events all go through the leader.
Excuse me?
Pardon? Oh,
Repeat the question.
yeah, sorry, I'll repeat the question. So the question is, because the session stays alive, how does it stay alive? And the answer is that all session events also go through the leader. So I do believe that sessions are stored not just on the node that you're attached to and not just in the client, but also in the other nodes of the cluster. And so you can reconnect to another place and reestablish.
Oh, okay. I'm not sure what a session event is in that case. Because so a read is not a session event, obviously.
No. A session is like literally the state of the client being connected to a server. That is like the session. The open socket, as it were, is the session.
If you, for example, if the client node can theoretically have a disconnect event, obviously, in the middle of a read.
Not in the middle of a read because of the way that, I mean, there's not, I suppose like...
If someone blows up my server...
Someone blows up your server in the middle of you processing a read, yes, you could have a session disconnected event, but you would see the read event as sort of a singleton event, and then you would get the results from that, or you would get a disconnect.
What if they purposely blow up your leader?
And so if the leader goes away, the remaining cluster will re-elect a new leader. And so the cluster itself will be unavailable while it's selecting a new leader, meaning it won't respond to requests. But once the leader is re-elected, the cluster will continue to process requests. And I can't remember if you see an event, if the clients see an event when that happens. They probably do, but I don't remember off the top of my head.
So does that mean the session data will go away if the leader dies in between?
The session data will not go away now. Everything is replicated everywhere, so you really do not lose. It's very difficult to lose anything from this design because everything is everywhere to some degree of statefulness, some degree of sort of time lag. Yes?
Can you define, more practical, can you define what client means here? Is this the client to some people, or is it part of some larger thing that you're trying to facilitate on top of ZooKeeper?
Sure. Okay, so defining a client, this is simply any kind of thing that talks to ZooKeeper. So we provide a actual protocol. ZooKeeper, we implemented in Java and C natively, and so anything implemented on top of those that implements the ZooKeeper protocol that can actually talk to a ZooKeeper ensemble is a ZooKeeper client.
But the end goal isn't necessarily ZooKeeper, or the end goal is to talk to something else that's also connected somewhere.
Yeah, the end goal could be to talk to something else, right? So this client contains logic to talk to the ZooKeeper, but it actually may be using the ZooKeeper so that it can look up something else, something inside the ZooKeeper and find another system. Yeah. Yes?
Sorry, maybe another silly question. When the data is passing through client and everything is being stored in the leader, is there any limit on how much information or messages can pass through a client?
Is there a limit
some throttle impact
on how much capacity to client? So certainly, yes, there's a realistic limit as to how much you can send over the network. We recommend data-wise if you're actually storing data. So actually, that brings me nicely into the ZooKeeper data structure. So ZooKeeper data structure, tree of nodes. Root is actually / so forgive me, I did not put proper root in here. If you imagine you have node A can have children, it can also have data, so those things that look sort of like pieces of paper, that's data. So nodes can have children, they can have data, they can have both. And so you can store data in ZooKeeper, and you should, you probably will. The goal, though, is not to store a lot of data in the ZooKeeper. You don't want to have huge nodes because that's going to cause you performance problems, right? ZooKeeper is all stored in memory, and it is Java. So for those of you who are not JVM experts, maybe you all are. If you're a JVM expert, you know what I mean when I say you don't want this thing garbage collecting because you're going to start to see a lot of problems. And in particular, we just recommend that nodes, there's actually a limit set on the ZooKeepers for the size of nodes, and you have to override that default. If you want to go any bigger, I think the limit is 1K, maybe 10K, something like that. So pardon?
I think it's 1 megabyte.
Is it 1 meg now? All right, I lowered it way a bunch when I was working with ZooKeeper last, and so I recommend much less than 1 meg. I think 1 meg is a dangerous size of data to put in a node on ZooKeeper, particularly when you're talking about something that's going to be living in memory. So those are some of the practical limitations of getting data to and from the ZooKeeper. You don't really just want to stick a ton of data in there. The more data is in the node, the longer it's going to take to process. Yeah?
Is the depth of the hierarchy of the data structure also a problem? You have too many.
The depth of the hierarchy, I mean, not really. The nodes themselves are not that big. So if you have a ton of nodes, at some point it will become a problem. I forget the exact measured size of nodes at this point. We've done the analysis. I think we've shrunk it a little bit recently. But the nodes themselves are not that big. So the depth of the hierarchy is not that big a deal. What can become, again, it's Java system. So if you create a bunch of things and then delete them and create a bunch of totally different things, if that data gets really big and you start to get into full garbage collection mode in your ZooKeeper, you're going to kind of hit some pain because sockets don't really work well under full GC in Java. So that's something to keep in mind. But most part, people don't have too much problems with that. Yes.
So I had one question. With respect to the ZooKeeper data structure, is everything completely stored in the heap, or are there options to move it into a map method?
No, everything is stored in memory. Yeah, there is no, right now we have no roadmap for storing any ZooKeeper data anywhere other than in memory. I don't know. Who knows what Facebook is doing? But besides that, nobody I know is working on that. So.
Most systems moved from heap to mmap implementation since the new version of Java. So it is accessible easily. It is in memory, but not the Java heap. So
I think that's a reasonable question. It's accessible, but it's not in Java heap, so you don't have to worry about the garbage collector looking over it. Right now, most people don't. If you use ZooKeeper for the 99.9% most common use cases, you're not going to have any of these issues. So it's really more of a problem if you start using it for really strange things. Yes?
I think all these questions relate to, people are asking, ZooKeeper is not meant to be used as a data store.
ZooKeeper is not meant to be used as a data store, correctly.
If you do that, then you don't really need that kind of memory. You just look up tables, you go through there, and go your way, right?
Yes, exactly. ZooKeeper is really not meant to be a data store for large amounts of data, right? It's just not, that's not what it is. It's a coordination service. It's a distributed locking service. It's not really a data store. So here's the data structure. One thing you'll note about this data structure is that we have one node that's sort of shaded differently, and it has a client connected to it. This is one of the key aspects of ZooKeeper that you will use if you use it, which is ephemeral nodes. Those are session-based nodes. That means that when the client goes away, the node goes away. That's super, super useful. If you are using ZooKeeper, for example, to determine who is alive and available in your cluster so you can sort of manage sending jobs to them, if those folks are advertising themselves in ZooKeeper by creating ephemeral nodes, the minute they die and their node goes away, you don't have to worry about pinging them or cleaning up. You can say, okay, they can't see the ZooKeeper, I'm going to consider them dead. And I can continue, sending my tasks to the remaining live nodes. Another feature that I will just quickly point out is also that we have sequential nodes. This is E00001. You can have, ever-increasing sequence numbers on nodes, which is useful for unique naming and a few other things. So nodes can have data, children, or both. Ephemeral is associated with the session that created them. So remember, as I was saying, clients, if they are attached to a ZooKeeper quorum member that fails, their session will still remain alive if they reconnect to another member. That's useful when you've got ephemeral nodes written, right? That means that those nodes will not go away and you won't have to recreate them as long as your session doesn't actually get disconnected. So the second major sort of basic feature of ZooKeeper is watches. What are watches? So watches are a way for you to be notified when some piece of state changes in ZooKeeper. Here's how it looks. So you want to put a watch on some data for a node. So get data from my node foo. True indicates I'm setting a watch. And the node returns the data that happens to be in foo right now, which is my data. Now, if another client goes in and says set the data in foo to be bar, right? Then once that set has been acknowledged, the notification goes to the client that put the watch that says, hey, the data in node foo has changed. You were getting a watch on this event that you registered. That is all you know, is that something has changed. You do not know what changed. You do not know how many times it changed. You just know the first time that it changed, you have been notified. So now, if you want to see, well, what was the change, you call get data again. Then in this case, we're resetting the watch with that true. And now I'm saying, oh, okay, the data changed to bar. Watches are tricky to think about because they are one-time notifications. They are not events. It's not like you can use a watch to say, every time somebody does X, Y, or Z, tell me, tell me, tell me, tell me. I want to see every single change that happened here. That's not the point of watches. Watches are more about observing a state change and less about having a perfect event stream coming to you. They're ordered with respect to other events, watches, and asynchronous replies. So you'll see a watch event for a node that's watching before you see the new data corresponding to that node. So you could not possibly read data from a node and get back the new data before you actually saw the watch notification to your client. And the order of the watch event corresponds to the order of updates as seen by the ZooKeeper. And again, one-time notification, it must be reset. So the point of this is not so that you see every single change to a node, but rather that you know when a node changes so that you can go and see what changed, what this new state is. And maybe the new state is the old state because it changed and then it went back to what it was in the time between when you got the notification and when you acted on it. That's okay. That's all we guarantee here. Any quick questions about watches? Great. So basics, creation API, create, delete, set data. You can take a lot of everything in ZooKeeper has ACLs. So that's kind of nice, except that the ACLs aren't recursive. So if you have a parent node with some ACLs on it, you create a child node of that parent. It's not going to have the parent's ACLs. That's really annoying. Actually, it's really, really annoying if you happen to care about that in production. You have to write a client that will always respect the parent's ACLs and propagate them to children. It's unfortunate that that happens, but these are the creation API, the get/watch API. So these calls will get you some sort of state, and you can use them to set watches. Note that pretty much all of these can be run either synchronously or asynchronously. So if you run it synchronously, you will wait for the results to come back from the ZooKeeper. If you run the asynchronously, you'll actually pass a future in that will be sort of triggered. Actually, I don't know if you pass a future in Java. It'll put it on the event queue anyway. So you'll actually see it as events. You can get more throughput if you run it asynchronously. So if you really, really care about throughput to ZooKeeper, you use the async calls versus the sync calls. Finally, we have a couple more or less basic things in the API. New in 3.4, we have multi, which is actually pretty cool. You can chain together a group of operations, send them to the ZooKeeper. They will either all succeed or all fail together as a group. You will not get sort of partial success or failure. This is useful if you want to do certain operations. You know, it's pretty nice. I recommend you checking it out if you have anything you think would be good with that. And then there's sync. So what does sync do? Sync helps the ZooKeeper make sure that it's actually in line with the latest update to a node before you read it. So one thing about ZooKeeper is, again, because it has that quorum, so you have a leader and followers, if your follower that your client is connected to is a little bit behind the leader, it can only get so far behind the leader before it will be cut off. But it can get a little bit behind the leader, and that means that it may not have seen the latest update to a particular node. If you really must have seen the latest update before you read something, you use the sync command to pull that data into that follower. And make sure, and that will slow down your reads, but it will make sure that you're seeing updated data. Yeah.
You just said what our ZooKeeper very key to the consistency, but how
Yes.
how it works.
Yes, so it guarantees consistency insofar as you're never going to see, you're never going to see writes out of order. You're never going to be able to read something that hasn't been acknowledged by everyone, but you can get, one node can get behind to a small delta from other nodes. So that is the one thing. It's sort of, there's an eventual consistency element there, and that's what the sync command is for. It actually lets you force a more real consistency there. Yeah?
Since everything is consistent and persistent, I'm just trying to understand why do we need watch? Because every time it sends what is an alert message, kind of. But any way to turn off the watch?
So why do you need watches? I'm not sure I understand.
Everything is persistent and consistent. If the reader is down, nothing will be saved. It won't allow you to go further. Everything is like two-phase comment kind of.
Yeah, but the watches are just notifying somebody else that's interested in knowing that data changed. That's all it is. So you don't have to poll. So imagine that you are implementing dynamic configuration in ZooKeeper, which is a common use case, right? You want to know when the config changed, but you don't want to have to, if you put it in a database or in a file system, you'd have to be polling and see, did the file change, or did this flag get written, or whatever. Okay, now I'm going to reread the config and see what changed. ZooKeeper will just tell you. You set the watch and say, tell me when this changed. Okay, something changed, and I'm going to reread my config. So that's the point of watches.
Is there any way we can stop watches? Is that possible right now?
Stop watches.
3.4 or 3.5 version of
You don't need to, you set watches if you want. It's just
Yeah.
about publish, subscribe with the async. So if you want, you can set it. You don't have to set it.
Yeah, watches are not a required thing. It's just a feature. All right. So moving on quickly, just common uses. I think common uses basically fall into two major categories: service management and distributed logging. There's a lot of different names for service management, a lot of different words, but I think that pretty much most of the things that people really use this for are service management. That includes coordination. So Storm, all of you guys are familiar with Storm. ZooKeeper is the source of communication between Nimbus and the supervisors. What does that mean? That means you've got the stateless Nimbus that is sort of the master whatever, that can come up wherever. And you've got these supervisors that come and go and are, maybe you add more, maybe you take more, some away. Instead of having to write a protocol such that the Nimbus and the supervisors could find each other and sort of know where each other are and say, oh, okay, well, we know that this guy's there and is alive and healthy, yada, yada, yada. They just took the easy way out and said, you know what, instead of trying to write our own protocol to find each other and make sure everyone's alive, make sure everyone's kicking and working well, we're just going to use ZooKeeper. They're going to write stuff into ZooKeeper. Nimbus is going to look into ZooKeeper to find the supervisors, and then it will connect to the supervisors and send them work. But we don't actually need to write a protocol for finding each other. This is just a hugely common use case for ZooKeeper. It's a very good one. Discovery, as I mentioned before, right? If you're running a big SOA infrastructure, this is one of the biggest things I've done with ZooKeeper is run a really giant discovery server. You can use DNS for this, but it's kind of a pain. You can use ZooKeeper and it works quite well. You want to find services that are doing job products. So you encode that job as a path in ZooKeeper, and every server that comes up running that service is going to register under that path. And maybe they say things like, I'm running version 4 of the protocol, I'm running version 5 of the protocol, whatever. I have 10 clients connected, I have 100 clients connected. You can use all of that information as much as you want to actually sort of encode where your services are running and let clients use the ZooKeeper to find the services that they want to connect to. This is a first-class use case for ZooKeeper, very easy, very well implemented. Configuration, as I just mentioned, read configs from nodes, watch the nodes for config changes. Very, very simple, straightforward, and robust. If you want to do dynamic configuration, obviously dynamic configuration has some risks to it, but if you want to do it, ZooKeeper is a great way to do it. And finally, locking. If you are doing distributed locking and you are not using ZooKeeper, you are crazy. This is, I don't know what else is out there that does truly safe distributed locking. If you actually really want safe and accurate distributed locks, I think ZooKeeper is the way to do it, personally. What does that mean? That means you're implementing barriers and latches. For whatever reason, you've got a bunch of processes out there running. You want to make sure all of them have completed something before they move forward. Great, use ZooKeeper. You want to use shared locks. Sorry, this is weird and out of order, but you have a shared lock. So you have a couple of processes that might be pulling data from a queue that's destructive, right? So you can only have one process actually pulling data from that queue, but you want to have a hot backup available in case the main process goes down. You can use a shared lock or sort of a leader election style algorithm to implement that. Also, if you want to do any kind of two-phase commit, guarantee that a majority of my followers have seen a piece of data being written before I actually commit that data to disk and I say, okay, I believe this is solid, right? That's almost the fundamental of the ZooKeeper algorithm itself is sort of a two-phase commit type thing, and this is just exposing that so you can actually use it yourselves for whatever you need to do with them. So those are the major, again, high level, I said this was for beginners, those are the major high level use cases. There are recipes out there that implement all of those things. Because this is the scary part of ZooKeeper. Look at my kitten, he's so scared. No love for the cat, that's right. This is the client-side state machine of ZooKeeper. Maybe this doesn't look that bad to you. I can promise you as an implementer, this is kind of a gigantic pain to get correct and actually parse and operate on correctly. There's a lot of different states that can happen, and you have to parse them correctly, and they're coming in on a separate channel from other operations. You have to know, oh, you're in a session expired state, so I have to close my connection and reconnect to the ZooKeeper. I'm in a connection lost state, so I'm just waiting to be reconnected, and hopefully I will reconnect properly. Oh, my auth failed, I have to completely close, clean out my connection, and reconnect. This is all kind of difficult to deal with, and I personally recommend not having to deal with this if you at all possibly can. In fact, I recommend saying nope, 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 nope to all of that because it's really very painful, and instead using one of the best-in-class clients. If you're in Java, as many of you who are in Storm probably are, possibly are, Curator is a pretty good one. In fact, Curator is what Storm uses. That's a client out of Netflix. It also implements a ton of those recipes, those sort of common use cases. So if you have one of those common use cases, you use Java. Curator is a pretty well-supported library, pretty easy to use, and you won't have to think quite as much about it. Kazoo is a Python first-class ZooKeeper library. They actually implemented the protocol. It's pretty awesome. I know the guy who wrote it, and he is pretty awesome. So I would definitely use that if I were using Python ZooKeeper. Twitter Commons also has a few utilities for ZooKeeper, namely discovery, but a few other things. So if you happen to be using Twitter Commons, you've already got ZooKeeper. Almost all the big sort of SOA framework, web framework systems in Java now have somebody that's done a ZooKeeper binding client for them somewhere, right? I think DropWizard has a Spring, Play probably has one. So if you're in that SOA world, if you're in that web services world where you're interested in discovery, you can probably find someone has written that code for you out there, and I recommend go ahead and use it. It's probably fine. Yeah?
Is there a C, C++ client available, you know?
Yeah, ZooKeeper itself provides a C client. You know, not the ZooKeeper client, C client?
Really...
Yeah, it's not amazing. It's not amazing, but it is unfortunately the best I know of. I don't know that anyone else has written a C client. The C client in the ZooKeeper library is at least pretty heavily tested. So there's that. And we made it work for C++-ish, but I know it's not amazing. If you want to compile it in Mac OS X, it doesn't work right now. It's really annoying. Well, not in the branches that we're working on. So. But, you know, it's definitely out there, available, and the C client is heavily used by a number of people. In fact, the new multi-API was created by someone who really heavily uses the C client. So it's out there, it's in quite active use. So finally, I leave you to the advice with ZooKeeper, which is that you should be aware when you're running it. It's a solid system, it's very well written, but it does, in some ways, own your availability if you use it as a key part of your stack, right? So if you are relying on ZooKeeper being available for you to be able to find the services to connect to and do any work, Or if you're relying on ZooKeeper to be available for you to be able to become the leader and pull from this pipeline, or if you're relying on ZooKeeper to be available to hand work off to task workers, if ZooKeeper is down, you're done. Now, you can architect around this to some extent. You can just sort of accept that this is a key part of my system, but I'm going to try to limit its use to only the really, really vulnerable and important parts and keep it there. ZooKeeper actually is pretty operationally sound. We don't see a lot of people having huge operational problems. Oh my God, my ZooKeeper blew up and I lost my whole 2 days of whatever, right? That's not a very common thing, but if you're going to run a ZooKeeper cluster in production, you should just simply be aware that it is an important piece of infrastructure for you. Put your alerting around it, read about the best practices of using it, put monitoring on it. You want to know if it's going to be in distress because it will cause you some pain if it does. The other thing I will note that I didn't forget to note in this talk is that Storm is using ZooKeeper very lightly. So if you've got a ZooKeeper cluster that's only running for Storm, you can use that ZooKeeper cluster for other things. The nice thing about ZooKeeper is that, especially in most of its open source uses, it's not used very, very, very heavily. It's necessary, but it's not like they're putting every single piece of state in it. And I, in fact, have read a number of places online where people have said, I just use the same ZooKeeper cluster for my Storm and my Kafka and my HBase and it's fine. And I can't promise you that that will be fine, but I can tell you that there are people out there doing it. It's a fine piece to have as shared infrastructure, as long as you have people paying attention to it, monitoring it, and making sure it continues to be healthy. Because misbehaving clients can cause problems for everyone else. Yeah?
Also, just one more thing. ZooKeeper has a pretty good CH routing technique, so you can CH route every other thing.
Yes, they have a good CH route technique that I've never personally used, but yeah, that is built in so that you don't have to worry about what my root node is, if I'm using it for this project, that project, or the other project. I'm just automatically in the right place. So that is all from me. Thank you. Somebody helped me with somebody whose slides I found on the watch slide. So this guy is ZAA, I don't know him, but he was very helpful. Thanks to him. Again, tweet me if you have questions. That's my email if you want to get in touch with me. Here's some links to some of the clients. You can Google them yourself, but I put everything in the slides. And Rent The Runway is hiring if you happen to be looking for something very different. We're actually a very cool place to work. I'm happy to tell you about that. But, more questions?
I know this is a Storm meetup, but can you just quickly, in like 5 minutes if it's possible, explain how ZooKeeper is used in Hadoop and HBase, because that is, at least for me, the other great idea.
How is ZooKeeper used in Hadoop and HBase? I am not a super expert at how it's actually used in the systems. I know that at least one of its uses is for task assignment. So, I know all these nodes are available. I'm going to assigning my tasks to them. I am not an expert. I'd have to reread it. So if somebody else knows.
I think it's more for service management.
Yeah, service management stuff.
We use it for our MapR M3 Hadoop cluster.
Yeah.
We need a ZooKeeper node, and also we run M7 HBase, and we need a ZooKeeper node. But with MapR, you have the job tracker that keeps track of assigning tasks and but I think ZooKeeper is just kind of like managing a distributed file system and knowing where things go.
Yeah.
So my specific question was, I didn't want to get too detailed, but maybe this, if you can answer it quickly, otherwise we can take this offline. But you got the HDFS, so you've got a bunch of regions that are created on various nodes, and it's distributed. Now, HBase is acting as a client that is using ZooKeeper to see where the regions are located, and that's the master, and not the master, but the leader and the slaves that you talked about. So if one of those fails in the region servers, like the location, I can't get to that. I just was wondering how the failure, like you talked about a two-phase connect, right? Wherein you're trying to keep, does it use two-phase connect, or does it because there's an HBase connect and an HDFS on the file, or?
I'm sorry, I could not answer that question. I'm sure I could find the answer for you, but I do not know the answer off the top of my head about how that works.
Yep.
Yeah.
Is it fair to say that the future efforts in development in ZooKeeper will be targeted to accommodate the Apache family of big data software?
Is it fair to say that they're targeted to accommodate the Apache family of software? Sort of. I mean, honestly, like ZooKeeper is, so ZooKeeper is one of the very few products out there that has nobody whose full-time job, as far as I know, is to support the open source version of ZooKeeper. So it's a project that moves slowly. Partly, it also moves slowly because it has to be reasonably solid before it goes out there, before we put our stamp of approval on there. Because we don't want people using this as a system that they really, really heavily rely on, and then all of a sudden ZooKeeper's losing data on you. That's really, that's not our point. A number of the committers do work for like Cloudera or Hortonworks, so they are out there in the Hadoop community thinking about how HBase or whatever HDFS needs to be using ZooKeeper. But actually, most of the future development on ZooKeeper has been of two types. It's been academic, so 3.5 is actually going to have reconfiguration of the ZooKeeper cluster, so you will not have to actually take the cluster down to reconfigure it. That's a hugely complex, like literally published academic papers worth of complexity. So that sort of one side of development actually comes out of research efforts from various companies. That was actually out of Yahoo, but out of various companies. And then the other side actually comes from large companies like Facebook and Nicira and places like that, even Goldman Sachs when I was there, that are using ZooKeeper in very sort of enterprise or really, really large scale ways that it doesn't quite work as well with right now. So Facebook has a number of patches out there that we're working through to increase the ability to handle connections or have many, many observer nodes or process certain data faster and really even improve the throughput of ZooKeeper because they're just putting a ton of stuff through ZooKeeper. So those are actually the biggest changes to ZooKeeper are actually coming more from new clients using it, new distributed systems being built, and enterprise and academic efforts. Really, actually it's fairly stable in the Hadoop family. But in the Apache family, I mean like Kafka definitely pushes certain things in sometimes, so that client also has caused a few changes in ZooKeeper since it's been created.
Well, it's just fair to say it's guaranteed that you'll work with most of the Apache stuff at minimum.
Yeah, I mean, it will definitely work with the Apache stuff. I mean, we certainly, I'm sure that all of the like Hadoop things are certifying themselves against a version of ZooKeeper so that they know that they run together. But we don't do a lot of backward breaking changes in ZooKeeper, so you don't have a lot to worry about there.
With respect to the reconfiguration APIs that you mentioned.
Reconfig.
Yeah. Have you known anybody who is using it in production or?
I don't know anyone that is definitely using it in production now.
It's a really cool paper. We tried building it, we've been unit testing it, it's been stable, but we're a little scared.
I would be scared to put it in production personally. Yes. I would leave it in stage for a very long time. Yeah.
Any company commercializing ZooKeeper?
Commercializing ZooKeeper, no. No, like I said, we can't even get anyone to be working on it, the open source project full time. We're all like very, very part-time committers. So it's just too, what are we gonna do? What are you gonna sell this for, right? That's actually one of the nice things about ZooKeeper. It works pretty freaking well. There's not really a lot of need to, put extra special bells and whistles and shine on it because, what it does right now is good enough for almost everyone. Yeah.
I'm not sure that I fully understood the part about the leader and followers.
Okay.
When you have about, let's say, a 9-node ZooKeeper cluster, right? Or cluster of ZooKeeper nodes, you only have one leader?
Yes, so you always only have one leader.
What does the leader do?
So all the rights go to the leader. So the leader is responsible for implementing the ZooKeeper algorithm, and that algorithm basically, at a very, very high level, works. So if you have a right, wherever it is, it goes to the leader. It's forwarded to the leader. And the leader then proposes it to all of the followers, and they vote on whether they will accept that proposal or not, meaning that they vote to say, I see this, it matches my belief of the sequence of events, I can write this to disk and acknowledge it. So they will vote, and as long as the point at which a majority of the followers vote to say, yes, this is good, then the leader sends a commit message, and everybody commits that. They acknowledge it to the leader, and then the leader sends that acknowledgement back to the client. So there's always only one leader. There can only be one leader. If there are ever two leaders, you could get out of sync, and you would not have any of the guarantees that ZooKeeper has.
And when the leader goes away, there's another leader that's elected.
So when the leader goes away, they go into a voting algorithm. And all of the nodes of the ZooKeeper that are still available will vote to elect a new leader.
No leader creating information is lost.
Right. Yeah.
And you set that up in a configure as to the all the nodes or the.
So you set in the config, you set up what all the nodes are. Right now, you have to configure exactly the location of all of the nodes in the cluster.
And then you can do it on every node, right?
And each node has the config in it, but you don't say which node is going to be the leader, right? Whichever node, gets elected when you first start up is the leader. Yeah.
So I'm fairly new to configuring ZooKeeper, I guess. I have to do it today. So I have two questions. First, in the config file, it specifies 2888 and 3888. Are those used, I guess, for internal communications between ZooKeeper nodes?
Yeah, the ports. There's a few different ports that are open. There's a voting port. There's and then there's like the actual communication, and then there's like admin ports. So I don't remember what corresponds
also,
to what.
I kept getting no node exceptions thrown. I'm trying to set it with Kafka, and I spent a lot of time on the internet looking for things. It seems to say that I need to drop into the command line interface in order to create like a root node. Like
You may need to for Kafka, yes.
Okay.
So I guess in Kafka, if you're getting no node exceptions, it means, often what it means is that it's trying to create a path, and one of the nodes in that path, perhaps the root, does not exist. That has to be created, at some point. Otherwise, you'll get a node exists exception. It already exists. So I'm guessing that to start Kafka up, maybe you have to actually create its root.
Okay, cool.
Yeah?
So I have a question from maintenance perspective. If, for instance, I need to upgrade my ZooKeeper cluster to newer version, how do I do that? Node by node or?
Yeah, so there's a sort of rolling upgrade that we recommend doing that will minimize your downtime. You should sort of Google ZooKeeper rolling upgrade, and it's documented somewhere. But basically, the recommendation is sort of node by node, you upgrade it. They won't be able to connect back into the cluster, and so you'll swap from having a majority in the old version to a majority in the new version. And your clients will see downtime, and they will see their sessions get disconnected. They'll have to reconnect. But other than that, it should be fairly seamless to your clients. It's actually a very small amount of downtime.
Just make sure your leader is the last one to be updated.
Yeah. Yes.
When your leader goes down, the cluster becomes unavailable, right?
When the leader goes down, the cluster is unavailable until a new leader is elected.
And the session from client perspective is broken, and client should reconnect again.
I don't think sessions are broken when that happens. I think the clients actually get a disconnected exception, but when the new leader is elected, their session should still be alive, as long as they're alive.
I'm just trying to understand from client perspective, is ZooKeeper become a single point of failure and we have to deal with it somehow? Or client is smart and will reconnect them somehow?
Client should be smart enough to reconnect as long as ZooKeeper is still alive. So like I said, like I showed in that diagram earlier, if the node that you're connected to goes away, the clients that exist up there are written in such a way that they will reconnect to another node in ZooKeeper. And if the leader goes away, but you were connected to another node, ZooKeeper will elect a new leader, and then you'll be fine.
And how long this process actually take? Because HBase, for example, take like a long time, a few minutes to select a new leader. What about?
It shouldn't take a few minutes. That's pretty. I have never seen a few minute long leader election, so I don't know what's going on there. I'm very interested to hear more details about it. Leader election should be pretty fast.
Depends on the network and the hard drive.
I'm sure it depends on the network and the hard drive, but it shouldn't take minutes. It should take maybe seconds, if that.
Is encryption available for communication among these nodes?
Among the ZooKeepers, I don't know. We do support SSL to the ZooKeeper.
By client?
By the clients, yes, that's like a new feature of 3.4. But I don't know about actually within the ZooKeepers themselves.
Because nodes can be like one on this part of the world and the other.
Yeah, yeah.
So,
I don't remember whether that actually, I think it's just clients to ZooKeeper. I don't know that it's within intra ZooKeeper, as it were. Yeah.
Just a quick question. Have you tried using ZooKeeper across multiple data centers and you have checked the latency?
Yes, and that's very much, I have done a lot of work actually with ZooKeeper across data centers and particularly across global data centers, and yes, but that's like a whole other talk. But yes, I mean, you have to check the latency. It is an important thing. Yeah.
About how old is ZooKeeper as an open source project, and what's next on the roadmap?
How old is it? That's a good question. 7 years, maybe? 8 years? What year is it? 2006 is when I think it came out, yeah. So that would make it 7, 8 years, something like that. What is next on the roadmap? Well, we're really very hard trying to get 3.4.6 and 3.5 out the door. It's taking a very long time. 3.5 has dynamic reconfig. It's its major new cool feature. There's also a few other like interesting sort of performance optimization things in 3.5. Yeah. Sorry, and so that's what I know. Those are sort of the major things on the roadmap right now. We've got a big ticket backlog. You know, this is a project where it takes a long time to modify. So.
And just as a follow-up to that, if people are interested in diving in and helping out,
yeah.
What would you suggest?
If you're interested in diving in and helping out, we mark tickets as newbie. So look at the newbie tickets. We try very hard to pay attention when people, especially when new people, provide patches. So I recommend looking at the newbie tickets. I recommend joining all the mailing lists, reading a lot, and becoming, as much as you can, an expert in actually running ZooKeeper yourself, because really that is that's the most important thing, is that you are a person that truly understands the system. Yeah?
When you said you had it distributed across the data centers, did you have the users and followers distributed across the data center, or did you have clustered replication?
No, I've done it actually with single ZooKeeper ensembles across data centers. So the leaders and the followers would be in different data centers.
That was in the continental US or across?
In the continental US, but also across to Asia and the UK.
You do more than 2 data centers always? Or?
3 data, yeah, you have to do 3 data centers. So if you care about losing a data center, you have to have ZooKeeper running at 3 data centers. That's the same. It's the same sort of logic as if you care about, you know, losing nodes. You really want an odd number of nodes. If you want to lose 2, you have to have 5. If you want to lose a single data center, you have to have 3 data centers. It sort of goes the same way.
Unless you have the reconfig.
Until we have reconfig. So maybe reconfig will make a lot of people's lives easier, hopefully. All right, it's been an hour, and I'm tired, and I think you guys are all tired, so I'll be here for a few more minutes. Thank you so much for coming.